Very good morning, students. Today we can continue as usual the topic of physics, that is system of particles and rotational motion. Okay, so we are continuing about that moment of inertia of the different bodies. Particularly, you have calculated the moment of inertia of rod, thin uniform rod. Then after that we are considering the ring, okay, circular ring. Then after that circular disc you have learned, and then after that means but the different axes that we have calculated. Then solid cylinder that we have calculated, and hollow cylinder also you have calculated. For the hollow cylinder, moment of inertia about its axis we have calculated. Our axis of cylinder is mr square, and parallel tangent parallel to its plane, tangent parallel to its length, that answer will be 2mr square. I think so that was the last point that we have calculated or we have considered. Now next point, we have to calculate the moment of inertia of solid sphere. Okay, so for the solid sphere we have the only two moment of inertia. If suppose this is the solid sphere, okay, so this is the solid sphere. If I want to find out the moment of inertia of solid sphere about its any diameter, okay, so then that about moment of inertia of solid sphere about its diameter, okay, or we can also consider about its center passing through its center perpendicular to its plane, that anything you can consider, or about its diameter. So then your answer will be IC is equal to 2 by 5 mr square. How we can calculate? So that answer will be 2 by 5 mr square, where r is the radius, m is the mass. M is the mass of solid sphere and r is the radius of that solid sphere. Okay, so if I want to find out the radius of gyration in that case, so therefore kc is equal to under root of IC upon m. So therefore 2 by 5 mr square upon m will get cancelled. So therefore your answer will be 2 by 5 into r. Okay, so that is about its diameter. So that things we have calculated. Now we want to find out the moment of inertia tangent, about its tangent. Okay, but how that tangent? Tangent perpendicular to its plane, or we can say that tangent to that plane. Okay, about its tangent. So how that answer will be? Suppose this is the solid sphere, so you have calculated about its diameter, and this suppose tangent is there. Okay, now I want to find out moment of inertia about this axis. This is the IC that we have calculated, and suppose this is the radius. Okay, so now according to principle of parallel axis theorem, so your answer will be IC is equal to, or IO is equal to IC plus m into h square. Okay, so here IC will be 2 by 5 mr square plus m into r square. So can you tell me what will be the answer? 2 by 5 mr square plus mr square will be 5 plus 2, 7 by 5 mr square. What is the answer? 7 by 5 mr square. Okay, once you got the answer about that IO, then sir, what is the KO, radius of gyration? So that answer will be square root of 7 by 5 into r. Okay, so this is all about its solid sphere. Similarly, we can calculate moment of inertia of hollow sphere. Okay, which sphere we want to calculate? For hollow sphere. Okay, so here again, here that means the two axes we want to calculate about its diameter and about its tangent. So moment of inertia of about, that means hollow sphere, about its diameter can be calculated by using the formula, that is IC is equal to 2 by 3 mr square. Okay, instead of 2 by 5, so that answer will becomes 2 by 3 mr square, where m is the mass of the cylinder, r is the radius of that cylinder. And if I want to find out the radius of gyration, in that case IC upon m, so here this answer will be 2 by 3 by m will get cancelled. So here this answer will becomes root 2 by 3 into r. Okay, so that will be the your right answer. Now next point, if you want to find out the that is moment of inertia of hollow sphere about an axis tangent to its plane. So here in that case perpendicular to its plane, so IO is equal to again IC plus MH square, but here this answer will be 2 by 3 mr square plus m into r square. So therefore your answer will becomes, so 2 by 3, 3 plus 2, 5. So that is 5 by 3 mr square. And so therefore KO is equal to root of 5 by 3 into r. Root of 5 by 3 into r. Okay, so this is the moment of inertia of hollow sphere about its tangent. Okay, so once you got that all the moment of inertias, then we are able to find out, we are going to calculate the particularly the different numericals on that moment of inertias. Okay, so I will give some examples to you. You should try to find out that answers about the different bodies and different axes. Okay, I will give some simple examples to you, okay, about that moment of inertia. So you please write down the first example. Okay, so this is the first example. So write down the radius of gyration of a body about an axis at a distance of, means h has been given to you, 12 centimeter. Okay, from its center of mass is, that is 13 centimeter, means that is what he has given, KO is equal to 13 centimeter. Find its radius of gyration about its parallel axis passing through its center of mass, means he is asking to you find out KC. Okay, so now passing through its center of mass, so what will be that KC? So what formula you have? KO square, because you have calculated this formula is IO is equal to IC plus MH square, and from that you have calculated m into KO square is equal to m into KC square plus MH square. If I will cut the m, so then your formula becomes KO square is equal to KC square plus H square. But what he has asked to you? KC square. KC means radius of gyration about its that means axis which is passing through its center. So that answer will be KO square minus H square. So therefore KC is equal to under root of KO square minus H square. So can you tell me what will be KO here? 13. 13 square will be 169 minus H. H will be 12. 12 square will be 144. Okay, both are in centimeter. You can keep it like this. 169 minus 144, that answer will be 25. Okay, if this would be 25, then your answer will be 5 centimeter. Means KC will be, means radius of gyration which is passing through its center will be 5 centimeter. Okay, so this is the first problem. Now write down the next problem. Okay, so write down. Can I rub this now? This is the first problem. Okay, second problem we can calculate. Second problem, I will rub this problem later on. Calculate the moment of inertia of solid sphere. Which sphere he has given to you? Solid sphere. Okay, last case we have taken. Of a mass, he has given to you 10 kg. Solid sphere having the mass is supposed to be 10 kg. Okay. Then now radius is 0.5 meter. Radius will be 0.5 meter. Means R is equal to 0.5 meter. Okay. Rotating about an axis passing through a point at a distance 0.2, means he has given to you H is equal to 0.2 meter from the center of the sphere. Now you see here, this is the condition now. This is the sphere. This is about its diameter. Okay, I see, and he has given the H. H is here 0.2 meter. Okay. So here in that case, you have the formula for IC. IC is equal to 2 by 5 mr square about its diameter. Okay, I want find out about IO. Okay, so what will be the formula here? I will use the formula IO is equal to IC plus mh square. I can use this formula. If I want to use this formula, then what will be the answer? So that 2 by 5 mr square plus m into h will be now here in that case 0.2 square. Okay, so that all this is the SI system. Now put the values. 2 by 5. What will be the mass? 10 kg. What will be the radius? 0.5 square. Okay, so that is 0.5 square. Again mass will be 10 kg and 0.2 square. So if you can find out that 2 by 5, 5 2s are 2 2s are 4. So that answer will be into 0.25 square, 5 square 25, 10 raised to minus 2. Okay, plus 10, 10 into 2 square is 4 into 10 raised to minus 2. And calculate that answer. 25 4s are 100, 10 raised to minus 2, 10 raised to plus 2. Okay, 10 raised to 2 into 10 raised to minus 2. Here 40 into 10 raised to minus 2. So 10 raised to minus 2 will be out. So 100 plus 40. So that your answer will be 140 into 10 raised to minus 2. Okay, so that what will be your answer? 140 into 10 raised to minus 2 kg meter square, or that answer he has given 1.40 kg meter square. Okay, so that is correct, because if you are dividing by 100, so that answer will becomes 1.40. Okay, so that will be the your second problem. Next problem. Okay, so can I take a big problem or a smaller problem you want, students? Which problem should I give? A very simple problem I will give to you. Okay, very simple problem. So you should solve this problem. You write down a thin rod. Okay, thin rod of a uniform density, thin rod of uniform density has a length 0.1 meter, has a length 0.1 meter, and mass is 150 gram. Mass is 120 gram. 120 gram means 120 into 10 raised to minus 3 kg, or 12 into 10 raised to minus 2 kg. So that will be the mass. And what he has given, find the moment of inertia about its transverse axis. Okay, about its transverse axis. Okay, so and about its one end also, means second IO is also he has asked you. So uniform rod, so for that IC will be ml square by 12. So what is that ml square by 12? M will be 12 into 10 raised to minus 2. Length will be 0.1 square by 12. 12 will get cancelled. 10 raised to minus 2 and here 10 raised to minus 2. Okay, what will be the answer? 10 raised to minus 4 kg meter square. So that will be the about its which one? That means passing through its center. Okay, and perpendicular to its length. And one more problem he has asked to you. Okay, so that problem is find out which about its IO. About its IO means which point he has asked to you, that is about its one end, and that answer will be by principle of parallel axis theorem. You will be able to find out ml square by 3. You will be able to find out that things. Okay, today we'll stop here. So the next time we can proceed for the rotational kinetic energy, how they are related with each other with the linear kinetic energy. Okay, today we'll stop here.